Hi friends, welcome back. Today we're talking more about real-world exponential functions. This time we're going to be talking about compounding continuously. In a previous video, I told you I hear often, when am I ever going to use this in real life? You know what? In algebra, especially in algebra 2, this is one that you actually really will use in real life. If you take a look at these exponential functions, the biggest place that you'll see it is when we talk about money. So when we're talking about mortgages, which is buying a house, or car loans or credit cards, things like that, we have compounding, and this can be a little tricky. So we're going to talk today about compounding continuously. In previous videos, you've talked about compounding monthly, quarterly, daily, annually, that sort of thing. I want to take that and compare it to compounding continuously. So first, let's compare. Let's say we have $10,000, and I'm sorry that blue is not as bright as I thought it would be. I won't use that one again, but it says $10,000, 8% interest, and 15 years. All right, so what I want to do is compare those annually, quarterly, monthly, daily, and then we'll talk continuously. So if we do that, in a previous video, you learned about this formula that we use. We take the starting amount, we do 1 plus the rate over the number of times per year. All of that is to the power of the number of years times the number of times per year. So if you figure those out, you'll see that you get these numbers. Compounded annually is 31,721. And if you compare all these, you'll see that daily is the best. If we're getting interest on this, we get 33,000 as opposed to 31 if we compound it daily. Well, even better than daily is compounding it continuously. So what we're doing is we're taking that amount, that annual interest rate, and we're constantly compounding it. So we're looking at that account to see what you have in there, and we're adding interest every time we're looking at it over the life of that year, the year annual interest rate. So we're dividing that up. It can be a little crazy and a little mathematically wonky. So we have this wonderful formula. I call it the PERT formula because it says P-E-R-T, PERT. So here's how PERT works. P is your principal. I probably should have written that in there. Sorry about that. P is your principal, which is your starting amount. Principal. Your R is your rate, and your T is your time. Now that E is just a funny number that shows up. You know how we have pi, where you take the circumference of a circle and you divide it by the diameter, and no matter what the circle is, you get 3.1415, yada, yada, yada. Same thing for E. It's just this naturally occurring number that occurs when we're compounding things continuously. So we have our little E button, our E there that we can use. Okay, so what we're gonna do. All right, so now you've seen that I've filled everything in. We have 0.08 for the interest and 15 years for our T. Okay, so if I go to enter this in my calculator, what I'm gonna do first, just out of personal preference, I think this is easier. We always wanna do our exponent first, so I'm gonna do that part in my calculator, e to the power of 0.08 times 15. Now on my calculator, when I do this, I hit Shift E, and I get that little E there. I don't have to use a caret, though sometimes people do, so make sure on your own calculator you figure out if you need to or not. So I'm going to use parentheses 0.08 times 15, close my parentheses because I want it E to the power of all of that. And I end up with 3.321 blah, blah, blah. I don't have to write all of that down. What I can do is just take that number and multiply it by 10,000. So times 10,000. There we go. And I end up with oops, I hit 10,000 a few many times. Let's try that all again. So sorry about that. So we got we got 0.08 times 15 and hit times 10, 1, 2, 3 equals that. Okay, there we go. So I end up with 33,201.1, and I'm rounding, so 17, right? So 33,201. Now, compounding daily is really close to that, but compounding continuously is just a little bit more. So if you have the option to compound continuously, that is a better choice. Now, so that's what compounding continuously is. Now, let's talk about what happens if we have, we're looking for the time. So let's say we're looking for the time. All right, we're compounding continuously here. How long will it take for the money in an account to double if it is compounded continuously at 4.2% interest? Okay, for the money to double. In that case, we can use, let's just make up a number, right? Let's say $100. So 100 is our principal amount. Then we have E times our rate, which is 4.042 times our T, which we don't know. In this case, because it says how long, we're looking for that time. So that is going to equal, we want to know what it is when it doubles. So double 100 is 200. Okay. Now, in order to get that e by itself, we're going to divide both sides by 100. Divide by 100, divide by 100. And I end up with 2 equals e 0.042t. Now, let's say that I had tried something else, like $500. So I said 500 e 0.042t to the t power. And then I wanted to double it, which is $1,000. Divide both sides by 500, and you'll see that I get 2 equals e 0.042t. So it didn't matter what I chose when I go to solve the problem, I end up with 2 either way. Okay, I'm going to rewrite this guy. E 0.042t equals 2. Okay, we've learned that if our variable is up in an exponent, we have to take it from exponential form and put it into logarithmic form. In this case, we're going to use natural logs because the base of a natural log is e. So natural log e, and I'm writing it in there, but generally you don't see it written in there. You just assume it's part of our invisible math, right? Things that we just assume you know. So I'm writing it in there for now because what I do is I take these outer two, smash them together, and then to double check that I have put this into correct logarithmic form, what you can do is say, I use what I call the scorpion method, which is to say that I go like this. Draw a little scorpion, and I say this to this power equals 2. Is that correct? I have done that correct. Excellent. All right, so let me rewrite that. So ln2 equals 0.042t. Okay, we want to get that t by itself, and currently we are multiplying. So the opposite of multiply is divide. So we are going to divide both of those. So we get t equals natural log 2, 0.042, divided by 0.042. Okay, so the, make sure that focuses in there. So if we use it on our calculator, we go to our natural log button and we say natural log 2. I just hit enters because it makes it easier. Divided by 0.042, that gives us 16.5. So t is approximately 16.5. Now remember, we were looking for how long will it take the money? So it'll take 16.5 years to double that money. That seems like a long time, but one, it's because you're young now, it goes by fast. And two, you didn't have to do anything for that extra money. You started your account with $100, and now after 16 years, you have $200. You didn't do anything for that money. Imagine if you had put in $10,000. You would have gotten a free $10,000 just by waiting 16 years by doing nothing. So keep that in mind. That's part of this real world application of these exponential functions. It's all about the money and how you can make more and how you can get your money to grow. I hope that answers all your questions. We will see you next time.